It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmers Union Nice Coffee.
Hi guys, welcome to this video which is going to be all about water chemistry. So what we're going to do is we're going to investigate the different ways that we disinfect water and the equilibrium that exists within water chemistry, because that's really what you need to understand and know. So generally what we've always used for a very long time in terms of water disinfection, so in terms of getting rid of microorganisms, bacteria, anything within water, is we've used chlorine. Chlorine is a really good oxidizing agent. It's got the good ability to form really strong oxidizing agents itself within water. So if you take chlorine, if you bubble it through water, you produce the hypochlorite ion. Okay? The hypochlorite ion is a really, really good oxidizing agent. It's what we use within water cleaning. You also form hydrochloric acid in there, and within the hydrochloric acid, obviously we have H plus ions and Cl minus ions. And these H plus ions are important when we talk about pH in water chemistry, because they determine what happens to our equilibrium here. So we're going to bring back the principle of Le Chatelier and talk about the impact upon an equilibrium and which way it shifts when you change that equilibrium. So what we're going to look at firstly is we're actually going to look at what happens when we go low pH. Okay? So when we've got a low pH, what happens is that we are increasing the H+. So our H+ over here increases in concentration, okay? Because we're lowering the pH. Now what that does is that causes the equilibrium to want to shift to decrease the H+ concentration, and that's Le Chatelier's principle, okay? So because our hydrogen ion concentration is increased, the equilibrium is going to shift towards the left, okay? So that's our shift in our equilibrium, okay? So that shift to the left, what that does is that decreases the hydrogen ion concentration. But what it also does is it decreases the amount of hypochlorite ions we've got in there. So that shift in equilibrium to the left decreases our ClO minus, which is what we need in order to kill bacteria. So if your concentration is too low, your hypochlorite ion concentration decreases and you lose your ability to kill bacteria. Okay? What happens if we increase the pH though, is what we're going to look at now. Okay. So if we increase the pH, or have a high pH, what we're doing is we are increasing our H+ ion concentration. Okay? So our H+ goes down in concentration. I've got to make sure I'm saying the right thing for you, not to confuse you, sorry. Okay? Now the reason that H+ ion concentration decreases is because if you're increasing the pH, you're introducing hydroxide ions, OH minus. Okay? Those hydroxide ions will react with the H+ ions, okay, and decrease the concentration. What it's also going to do is it's going to form water. So we're going to increase our H2O concentration, decrease our H+ concentration. What that's going to do is have the net effect on the equilibrium of shifting it to the right. Okay? Now the reason it's going to do that is it wants to decrease the H2O concentration that we've increased and also increase the H+ concentration that went down. So what that's going to do is a shift to the right, so a higher pH is going to increase the formation of our hypochlorite ions, okay, which is going to obviously allow us to have more of the hypochlorite there to be able to kill bacteria. Now the downside of doing it that way is you start to get towards a very acidic sort of product over here as well, which obviously offsets your increase in pH. So it's a fine balance when you're doing water chemistry and trying to get the amount of hypochlorite ions available that you want. Okay? What we do is we normally have a pH of around 7.2 to 7.8, and that's the ideal. Alright, so I'll write that up here. So 7.2 to 7.8 is our ideal sort of pH range that we want when we're looking at trying to get a good bacteria killing ability within our water. There is some more chemistry around pools in particular, and keeping swimming pools really clean of water. So I'm going to show you that now. Is that you, Jeremy? Is that you, Jeremy?
Yeah.
How you doing?
Good.
Good. Just because in the middle, that's fine.
No worries.
I'm getting all creative now with my little water droplets.
Got some learn a voice student.
Okay, no worries. I'm almost done.
Alright, no worries. I'll run it past you because obviously it's always the timetable trickiness of trying.
Oh, cool.
Do you know what I mean? Like when they're new students?
Yep. No, that'll be fine. Two, one. So this is the second equation, and so this one now particularly relates to when we're looking at the chemistry within swimming pools. Okay, swimming pools, what we normally have is a hypochlorite that we add in, so either sodium hypochlorite or calcium hypochlorite, and they'll be granules. So they contain the hypochlorite ions here. Okay, when they get into water, what we get is hypochlorous acid and hydroxide ions. So this time it's a little bit different, the water chemistry we're looking at. But again, pH still has an impact upon the chemistry within a pool. So again, if we start by looking at a low pH, a low pH this time is going to impact upon our hydroxide ions. A low pH is going to decrease the concentration of the hydroxide ions because a low pH is going to have H plus ions. They will react with the OH minus to increase the water concentration. So again, what we're doing is increasing the water concentration as it's formed by decreasing the hydroxide ion concentration. What that's going to do overall to the equation is it's going to cause the equilibrium to shift to the right. Okay, so we're going to get our equilibrium shift this way, which overall is going to increase the concentration of our hypochlorous acid, and it's going to decrease the concentration of our hypochlorite ions. Okay. Now, remember the hypochlorite ions are what we use to kill bacteria. So if we're decreasing the hypochlorite ion concentration, what's going to happen is that we're going to remove our ability to kill bacteria and germs. Okay. So that's one downside of having a low pH. If we look at a high pH, the opposite side to that happens, and I'm just going to choose this colour because I haven't gone with this yet. So if we go with a high pH, okay, what we're doing is we're therefore increasing the concentration of our hydroxide ions like that. Okay. So an increased concentration of our hydroxide ions at a high pH is going to cause the equilibrium to shift to the left, all right, in order to decrease that concentration. So what that's going to do is that's going to increase the concentration of our hypochlorite ions. Okay. So what that means is obviously we get more hypochlorite ions, which is our ability to kill bacteria. But the problem is if you get a pH that's too high or too low one way or the other, you can obviously impact your ability to kill bacteria, and you will also sometimes cause issues within pools. If you've ever been in a swimming pool and you've got red stinging eyes, that's a really good indication that the pH is not right. Also, if you have a pool that's filled with algae, that's a really good example that you don't have enough hypochlorite ions. That's normally coming from where the pH might be perhaps a little bit too low, where you don't have enough hypochlorite ions here to be able to kill off the bacteria as well. Okay, so it's a really fine balance, and this is why we said we keep our pH to within 7.2 to 7.8 in order to maintain the right concentration of the hypochlorite ions, which are what kills off the bacteria. All right. Hopefully this has been fairly straightforward for you. Like I said, you might want to refresh about equilibrium and the Chatelier's principle if you weren't quite following on which way the equilibriums go. I just realised, sorry, that this if we're talking about equilibrium, this should actually be an equilibrium reaction, okay? Because that equilibrium can go one of both ways. But hopefully you've been able to understand the impact on the pH, what it has upon the concentrations of the species, and why the equilibrium shifts the way it does. As always, if you've got any questions, just ask, but hopefully it makes sense. And as always, have fun. Thanks, guys.